Hello friends, this question is from the test series number 10 from subjects of analog and topic name is operational amplifier and its applications. It's a common data question. In a problem we have a two-stage circuit of op amps in the first stage and the second stage, and question is asked that whether this combination is act as a band reject filter, band pass filter or band pass filter under certain conditions, or you cannot determine. These are the four options we have. We need to find out what kind of filter this arrangement looks like. You can see that in the initial stage, if this capacitor, we know that the capacitor has a capacitance of 1 by j omega c, right? My xc is 1 upon j omega c. So here omega is nothing but 1 by j 2 pi fc. So if I may put the value of f is equal to 0 or some very small value, for that very small value of 0 my xc will tends towards infinity, because 1 by 0 is infinity eventually. So for very small value of 0 my xc will going to show me a very high value, or contemporary or a high value. I will say, let us assume infinity or some very high value, my xc will going to reach towards 0. It means that for high frequencies my this capacitor will act as a short circuit, or for very small frequencies this will act as an open circuit. It means that this part of the circuit will act like a low pass filter, right? On the other hand, my C2 is again a capacitor. It also behaves the same. For low frequency of the circuit, the C2 will act as open circuit. So when this C2 is open, my entire signal from the first output of the first op amp will going to fed into the input of the second op amp. Okay. On the other hand, when my frequency will increase, then my C2 will be activated and it will short circuit this terminal. On the other hand, the second section is act as a high pass filter. So basically, we have one combination of low pass filter and high pass filter, right? So we know that the low pass filter has a characteristic of something this FL, right? And we have in series we have a high pass filter which has a cutoff frequency of high pass filter FH, right? So if I can say that we have one low pass filter, one high pass filter, but if we have this kind of situation, you can see that there is no overlapping between low pass filter and high pass filter. It means that my low pass filter is going to pass from 0 to FL. This is my FL point. From 0 to FL is going to pass by the low pass filter, and FH onward is going to pass by the high pass filter, but there is no intersection. It means that eventually we will have a null filter. Nothing is going to pass because they are connected in series. On the other hand, if I may choose the value such that my FL is basically going to overlap with a certain section of FH. If I may choose my R1, R2, C1, C2 such that I can get this kind of overlapping, then I can actually get a band pass filter. But in this case, you can see that the frequencies in the range of FL to FH or FS to FL going to pass by this network. It means that the circuit will act as a band pass filter under this condition. On the other hand, I can choose that either band pass filter or no pass filter, depends upon the value of R1 C1 and R2 C2, because we have seen that if there is no overlapping, then it will behave as a no pass filter or null filter. If there is overlapping, then it may act as a band pass filter. It means that my correct option is option C. Okay, option C is my correct option. Thank you.